we are still working on the Chapter 3 test ins, and we are on or about, what, test int number 11, 12, something like that? Okay. So in this question, we want to know why the metric system is so awesome, and why is it convenient? Why, what makes it so much easier for us to do?
Because everyone else on the planet uses it except the United States.
Right. And like
one day it's going to happen.
Yeah. And what does make it so helpful?
It's super easy to convert. All the conversions between all of the different units of a particular measurement are all exactly the same. It's all powers of 10. If you're converting between units of length, then you're either multiplying or dividing by powers of 10.
Right.
There's no silly, arbitrary, there's 12 inches in a foot, there's 3 feet in a yard, there's 5,280 feet in a mile. There's none of this kind of random measurements.
And we did that powers of 10 activity early in the chapter, and there was that awesome website where you got to zoom in and out and see the relative sizes of things. So go back and take a look at that again to refresh your memory.
Good.
Okay,
Number 13, identify metric prefixes and their relative size. So smallest to largest or vice versa.
And we had an example here. If we gave you answer choices of nanometer, kilometer, and centimeter, and we said, put them in order from smallest to largest. Well, you would need to know how nano compares to kilo, compares to centi, and which ones are big and which ones are small, and what is the whole range there. Yep. This is your King Henry Hector with the milk thing.
This is perfect for all you flashcard makers. All you guys that make stacks of flashcards this big for your Latin vocabulary, learn those metric prefixes.
Right, and that's what the Cootie Catcher helps you with too.
Yeah.
Okay. Number
14, identify SI unit of mass. This one, I don't like this one.
Why?
Because is it the base unit of mass,
yes,
or is it the standard unit of mass? Because the standard unit is actually the kilogram.
Right.
But the base unit, the gram.
When we're doing the stair steps and conversion.
Right.
But the standard accepted in the SI system is the kilogram for mass,
right?
Not pounds.
Right.
Don't put that down.
Please.
Okay, 15.
Oh, that's another one of this one. Compare units and distinguish the largest from the smallest. This one's particularly mass units.
Okay.
So back
So
to
yes, they should be able to do that.
Yeah.
Okay. And then, what is the difference between mass and weight? Like, don't we put them on a scale and that's just weight?
No. Well, yes. A scale tells you weight.
Yeah.
But in chemistry class, we use a balance, which tells us mass.
Mass.
Yes.
So what's the difference?
Weight is dependent on the force of gravity, on your mass. Mass. Yes, the force of gravity on your mass, pulling you down against the Earth. If you went somewhere else, to the moon or Mars, where gravity was different, your mass would be the same.
Right.
Your weight would change.
Okay.
Right.
I get it.
Unless your mass would be the same unless you threw up on the way to the moon.
Right. I would probably do that.
Yes.
Okay, so moving on to number 17, and it looks to me like 17 and 18 are very similar.
Yep.
So you're going to get values, we're going to give you specific quantities and ask you to convert to another quantity within the metric system. So you're going to need to know how to do conversion factors, like that above Mr. Sustin's head there. And what one thing equals the other. Go back and take a look at that video that we showed you with how to write a conversion factor as well.
And that actually takes us right into question number 19, which is about conversion factors or equalities.
Right.
These two are equal. This is a statement of equality. It's a definition. It's a fact. It's a conversion factor.
Right.
For every 1 kilogram, there are 1 million
So what might be an incorrect answer on this? Well, if we wrote down that 100 kilograms is 1 centigram, that would be
That's not right.
horribly wrong in
Right.
a couple different ways.
Right.
So make sure you're matching the unit to the magnitude of the number when you're reading this. And you know, this is another one, we told them this in the last test review, but read all the answer choices, look carefully. We have been yelling at you for a couple weeks now to make sure that you put units on all of your measurements, so that when you see test questions or when you're applying things in lab, you can figure out what it is you're doing instead of just trying to guess, well, do I divide this number, do I add this number, what do I do with it? Put the measurement unit on there so that you can manipulate the values properly. Okay, going on to number 20.
Number 20, approximate the size of a cubic meter.
Okay,
So this is 1 meter.
right?
We've got two
Okay.
others on the desk here. Length, width, height,
So something that would
fit in this area.
This would be a sweet box to play in.
all that
If I had some crayons and some scissors in a box this big, I could have fun all day on a Saturday.
all day long.
Yes,
Mhm.
that'd be awesome.
Yeah.
All right.
Yeah. Very good. So that should help you visualize.
21, define density and how it's calculated,
You know, they know this.
if they're not dense.
Right. Yeah,
Good one.
I've been good with that. They
Yeah.
know the equation for density.
Yeah.
So we're going to move on to
22.
22.
We'll take that definition and equation of density that you know and use it to calculate the density of an object when you're given the mass and the volume.
So you're actually going to have to apply what you know about the equation. And we are so nice. We're so nice. Because every answer choice is in the correct unit.
Correct units,
We didn't
Nice.
even try to mess them up that way. We got everything in the correct unit.
yes. But I should say, if you do the mathematics incorrectly,
Oh,
that choice is there.
uh-huh. So if you
So-
multiply, the
Or
divide.
divide
divide
the
the
wrong
wrong-
things,
yeah.
in the, or whatever.
That's tricky, tricky.
We're gonna find out exactly
Right.
why you got that one wrong, for sure.
And
All
so
right.
will you at test corrections.
Yes, you bet.
Okay.
Number 23,
Alright.
describe how the density of a substance changes if the mass or volume is increased or decreased.
Now, I remember them having trouble in this question.
Because they're in a different hallway. They're in the science hallway.
Right.
So their math brains switch off.
Right.
Right.
So try to visualize on this one, and I would say on this test of the multiple choice, this is probably the one you'd spend the most time on. Really stopping and thinking, maybe do a little sketch on your answer sheet of what this might be. From one volume to the next, what would happen to the density? Or one mass to the next, if the volume is the same, what would happen to the density? And I think drawing a picture of that will
Yeah.
help you with that. But I do know that this is one that,
Yep.
that people typically have trouble on. Okay, 24?
Identify correct units for density. If you know what density is, you should know what this is. But also, if you're reading your test, you should be able to look back and find it.
Right.
I hope
Okay.
no one misses that.
Yeah, I don't know if this is it either.
25, the last of the multiple choicers. Identify the quantity measured with a balance. Didn't, you just,
Right, well, you said it wasn't weight,
Right.
so it must be
volume.
the,
No.
no.
I think
No,
it's
I think
Time?
Mass.
Is it time?
No, it's not time.
Temperature?
No. Mass.
Oh, okay, thank you.